Sorry, yeah, I'm David Sandilands. My presentation is going to focus on how our delivery is evolving. We're kind of going from deterministic code, where we're kind of very sure about what we're delivering. We've all experienced can be very unpredictable. Um, we have these moments where we've seen the kind of disastrous chatbots go out that abuse people in public, or we've also seen the reality, which is kind of we get reports around 90% of AI projects are currently not reaching production. But what I believe is if we look at the evolution of delivery in DevOps and look at the past lessons we've learned and apply them to today, we can actually see that applying what we've learned and looking at today's problems, we can actually find it's just an evolution. It's not a complete change and revolution. So for today, I'm going to tell you a little bit about myself, why I'm talking about this kind of thing, the historic stages of DevOps as I see them, the current AI stage of DevOps, and the kind of lessons and conclusions we should take from this journey. So, yeah, I've been working for over 20 years. I started out in the Royal Bank of Scotland as a support infrastructure person, doing very traditional, completely manual work. I moved into Sky, where I learned about configuration management. I then came back to what was renamed the NatWest Group by that point, which kind of started to implement, into the more abstracted era that we'll talk about, where you kind of got this digital transformation even from the most traditional organizations. Having gone through a lot of this, I moved on to Puppet, where I had several hats. As a solutions architect, helping customers scale and understand their DevOps journey, as a product manager for the developer experience, and as a community lead for the open source part of Puppet. I've then kind of moved on to LaunchDarkly, where now outside of the infrastructure side, I'm working in that kind of code delivery area in terms of understanding flags, experimentation, and of course, like we're all doing nowadays, AI. And I had my own publications in terms of Puppet 8 for DevOps engineers, and I worked on the 2024 State of DevOps report. So I always kind of see this first stage in terms of like, as exactly as I was describing, my first job at RBS, where you had this kind of very manual era, where you had, if you've read the Phoenix Project, Brent was the main person who could get everything done. You had this kind of key person risk, where tribal knowledge on how everything worked created kind of major financial risks and also huge stress within teams. Um, Nobody wanted to be the Brent who had everyone relying on him and everything having to go through him when things got serious. We also ended up with snowflakes as a result of this kind of tribal knowledge, because every combination infrastructure and code kind of ended up uniquely handcrafted. In my own job, I as a support person, I used to sign off servers going live to production, and I could immediately tell who had actually built that server just from the little features you would see in terms of how it was made. And we kind of saw this kind of high error rates, difficult handoffs, and people defending the kind of limited views of their landscape, because you had support teams, you had developer teams, and they had very different motivations. For me as a support person, I just wanted to kind of keep things out because new things cause problems, and developers just kind of want to get things in with their set out project timescales. But the kind of DevOps developments in that first part, which were widely reported, in the very first State of DevOps report going back to 2013, was most organizations, really focused on standardizing hardware, standardizing on, specific OSs, particularly Linux, creating these DevOps teams where developers and operations work together rather than arm wrestled. And we saw the introduction of standardized version control and peer review to create a culture of shared responsibility to develop and understand code together. We then kind of moved into this declarative era, which was kind of this wild west of cloud, you know, the issue of coming out that first era was, we saw people kind of script more, but that kind of relied on a starting point, and trying to code for every scenario was just too complex. We saw huge maintenance debt getting built up. All these kind of, whether it was kind of bash scripts, PowerShell, Python, whatever it was, this just created a huge maintenance debt, which was also often highly customized to key individuals who created them. And we saw, this huge expansion of virtualization and cloud. And it just made it so much harder to try and maintain everything. In that first era, I still have a book in my drawer from my graduate training that told me the Royal Bank of Scotland had 200 Unix servers, which seems like a lot at the time. But when you consider the thousands and thousands and thousands of virtual machines and cloud components that can be created and destroyed within the blink of an eye, the scale just went out of control. So, we turned to configuration management. We declared how we needed things, and we used that kind of code to maintain them by abstracting away, from our simple kind of step-by-step code. We then had more continuous integration. We built and automated the test and release process, and we moved to far more flexible infrastructure. We instead of these kind of fixed capital data centers, we moved to the flexible capacity in the public cloud. And one of the most interesting things I think here is when we kind of talk about AI having this huge challenge in terms of how it's so different and how people are worried about the jobs being eliminated by how different it is. I had the exact same situations with configuration management because people were used to how their old scripts ran, and they saw the level of automation that configuration management could make compared to simple step-by-step procedural scripts. And their concern was that, these scripts are just brought in to replace them. And, ultimately, it would also mask how things were done, and understanding would be lost. But we quickly realized that through each of these evolutions, we keep abstracting away, and we build our understanding, by using kind of continuous integration and testing to ensure we're doing the right things. But as we continue to abstract, and I think every CNF cloud native landscape is never meant to be in a picture anyone can actually read. We started to just find this explosion of tools, and it became too great. And all these DevOps teams who were essentially having to pick out their own sets of tools, work out their own chains, were finding they had this huge cognitive load, and too much time was being spent maintaining their own environments. And we kind of hit these kind of velocity limits because, the CI/CD pipelines could only go so far. Releasing to production has its risks and slowed us down. And we then ended up with what I commonly found was, instead of getting down to the kind of minimal features you want to release, we kind of ended up with almost like bundles of things that we needed to release at points, just to match in with kind of governance, with what our pipelines were capable, and how much risk we were willing to take. So, and also in this kind of abstraction era, this OpEx instead of CapEx, so having operational expense instead of just, buying, data centers and hardware, while it was potentially much cheaper, by only using what we needed, we found that very, small mistakes could actually snowball. And I'm sure everyone in that era kind of saw a huge cloud bill come in unexpected. We also kind of experienced almost a desperation from leadership in terms of having this feeling their organization was not abstracting quickly enough. They knew they had to get to the public cloud. They knew, they were struggling to adopt for a lot of particularly large organizations, particularly regulated ones. And they made this idea that, things had to be cloud first, and that to force people instead of guiding them. And that, as we'll go on in to discuss how this stage DevOps actually helped, created more issues and more inappropriate cloud projects than actually helped anyone adopt properly. Because the developments we kind of saw in this era were, we saw containers and serverless doing the ultimate step of standardizing by stripping down infrastructure to the absolute bare needs. We also saw the kind of separating of release from deployment. You know, as we saw feature flags come in, we produced far greater control, and allowing us to be able to turn on and off features without having to feel we've kind of committed with the deployment. So that allowed us to shrink those releases right down and get down to pure features, and even just to be able to expose those features to appropriate sized audiences. And when I talked before about the cloud first initiatives trying to force people into the public cloud, what I think we were all desperate for at that stage was the kind of platform engineering we've talked so much about. You know, to reduce the cognitive load on engineers who don't need to keep reinventing the wheel, but can follow that kind of autobahn, that golden path, um, and have that conversation ideally with the product manager who is looking after your platform, about what they're needing. What is going to really serve them value in the public cloud? Because I feel like that stage of public cloud adoption was hampered by people struggling to translate what they had today into what they really needed in the future, and get over the kind of fears of how many things they had to choose, how they had to understand things like chargeback and monitoring, when in the old world they had very fixed costs and they knew exactly what they were getting and what they were buying. So that leads us into today, the probabilistic era, as I'm dubbing it. Um, as I discussed at the very start, we no longer have this deterministic code. Um, and we kind of have this feeling we're moving away from certainty about getting the same result each time. That it feels like a more seismic change than going from that kind of procedural code I mentioned to uh, configuration management tools like Terraform or Puppet. Um, because they felt predictable. If you put in the right inputs, you always felt like you would get the same result. Um, and we're also seeing this kind of a risk of the return of the key people. I have this feeling in so many organizations, AI feels so different and so complicated, many people are stepping back or even boycotting, to far larger scale, because we see people kind of dub AI as dangerous, or something we can't control or can't understand fully. Um, and yeah, it leads to this. Well, that's great for maybe for the kind of personal uses we'll all have, and for cutting edge organizations, but for the larger organizations, how do they make it so that they don't have to kind of feel like they spend a lot of money on experts, and have this huge clash between their production needs and the realities of AI. And we also see an even greater economic volatility. So even further than that public cloud era of trying to understand OpEx costs, you know, we can feel that as people are experimenting and trying various models, they can make very small changes, or even just trying out little things, but can find they can get huge consumption spikes, um, you know, even more likely than before. And I feel like all these problems I just described, we can kind of look back through that journey I just took you through, because we need to kind of build the platform up band for the AI era. A control plane is more important than ever. We need product-led platforms that act as a PM for the developer experience, that help standardize guardrails and reduce cognitive load, and allow the engineers to focus on the business purpose of what they're trying to do AI, and not worry about all the plumbing. Be that kind of the correct LLMs to use, the AI agents, MCPs, how they have to join everything up. We are needing platforms more than ever to give sensible options to people. And the decoupling of release, you know, it's more important than ever, because we do have to experiment with so many models. Um, we want to kind of do light exposure to real users, maintaining that kind of instant kill switch that feature flags give you, and give you that safety of not slowing down, not grouping things together, but being able to very quickly experiment on very precise groups of users, and groups of use cases, and make fast observations. Um, and you know continuing down the line of continuous governance. So we need to shift from kind of the manual gatekeeping to more automated sensors. Now we've been doing that through each step of this DevOps journey, but it feels particularly around AI, people are kind of holding on again because there's a feeling of getting to production is with AI is more dangerous than people have experienced before. And for me, one of the big things of platform engineering is compliance is this continuous byproduct of the platform. By making good safe, good guardrails, good choices for people, we allow people to have that kind of golden path. And we have the audibility baked in the pipeline, not something we kind of add at the end as an afterthought. And kind of, doubling down on change and audit, so as somebody who worked at a 300-year-old bank, obviously change and audit was a huge part of it. And I feel there's often this misinterpretation of change and audit as something that's in your way. For me, change and audit is one of the most critical parts we have to think about coming into any adoption of technology. There's often this viewpoint when you speak to organizations initially that change and audit actually have, very hard rules that are, completely unpassable as we see these technology evolutions. And we've seen it at each stage. When things like Puppet first came in and they were able to kind of make corrective changes, there was these huge outcries of that can't happen outside of a change window. And in the same way, we're getting these questions about AI. If we can't define exactly what it does, then that can't be a valid change. But change and audit are rarely clear must be done statements. They often require interpretation. If you look at, various audit rules, such as, PCI, these kind of big statements, they will have some elements, such as, data centers must be so many miles apart for disaster recovery. But a lot of it is statements of intent. And that's where it becomes so critical to kind of engage your change and audit teams because they all have good motivations and want to work with you. If you can explain what you're trying to do and how you're going to handle, the risk and approach they expect, to understand how you're delivering change into production, how you'll monitor that change in production, and how you can back out any issues that appear. And starting to use these change and audit processes as soon as possible prevents any executive privileges masking underlying operational problems. Because we often see this when you've got something as big as AI, you'll very quickly get to a stage where you'll have an executive leadership sponsor who will allow you to kind of skip through stages because delivering the project is too important. And that allows you to get lazy and it allows you to kind of get through a lot of problems and then maybe even get to production. Maybe you're part of that 10%. But then it gets to a scalability problem because if we haven't considered these things, then we end up with platform teams who have to, do lots of manual work to kind of massage change and audit through, at every stage. And one of the big things for me is observation is no longer optional. I love this quote from the observability engineering book about how monitoring is about the health of the system. Observability is about the health of the business and experience of the user. Because in the last generation, we've seen a lot of talk about observability, but I haven't actually seen a lot of it implemented. But we often just end up with kind of, big Datadog implementations, big Splunk implementations, lots of dashboards where in my old job, I would have been told, how are the Unix servers doing? And I pull up graphs and I say, they probably look all right, but we don't really understand, how are the users experiencing their journey? How is the business feeling things? And that's the most critical part of managing AI risk is that we have to have live observation and using again those feature flags we talked about to come in to make sure that we safely immediately manage where we see in our observability degradation of the user experience or business results. And business purpose. So we've got to understand what I have quite an aggressive headset that likes to turn itself off. We've got to understand what outcomes we're really trying to achieve from our AI projects. And I quote this book, Safely to Earth. It's got a great bit in it about one of the chaps who was working between IBM and NASA. And one of the things he wanted to do was he wanted to replace the tape machines with terminals so that instead of feeding things in, they could just type things out. It seemed the most obvious change to make. Like many of us who've experienced AI, it's just obvious that I need, you know, Gemini or I need Claude code or whatever it is to do my day-to-day job. But when he actually made this request into NASA, their response was, okay, great, what do we get out of it? And he hadn't prepared us for the meeting. So in fact, the engineering set next to him said, we'll save 20%. So the NASA guy said, that sounds great. I sign it off. You'll have 20% less resources now. And that's where we need to be clear what our success metrics are going to be and that they're visible to all stakeholders and that we're benchmarking where we are and our progress on a success plan so that we don't get cancelled, we don't get lost, and we're able to kind of keep everyone's morale up and understand where we're progressing or where in fact we need to review how we're working. So I'm aware I'm probably a little bit over time, but just to kind of give my my key takeaways here, I feel like that DevOps journey we need to double down on our DevOps principle. Maturity is cumulative, and we must build from a very strong foundation. So ensuring we're actually following everything we've learned over that time, that we have solid platform engineering, that we're helping everyone come on the journey, and truly working as DevOps teams, that we're convincing and evolving with change and audit. We've got to be building and developing these principles as we go, and learning as early as possible how we can actually work to avoid scaling issues when you become a standard and you have to follow all the production rules to letter. Observability is no longer optional. AI requires constant monitoring of user and business, and it's no longer good enough to do the old style monitoring and kind of react to issues we see. And probably the most important thing for me, for all, is we've got to have measurable aims. We must understand, our current position, what we're going to achieve, and show the iterative progress we are making. Otherwise, once the AI buzz, dies down, which it eventually will, we will find ourselves unable to defend the platforms we've made, and ultimately just kind of running things down, or with things that teams have to maintain at great pain to themselves. So at that point, any questions?